All right, so today's lesson, I'm going to be telling you guys some basic rules of logarithms. And we're going to be using these rules in order to solve equations that have exponents in them. This is kind of the whole point of logarithms is to make solving these a lot easier, okay? So the first rule you need to know is anytime you have log a to the x power, that's the same thing as saying x log a. X times log a. You're just taking that x and putting it to the front.
Is that log not, is that base A?
No, it could be base 10. If I don't have a base written there, you can assume it's base 10.
I'm just wondering if you wrote it. Like,
No, I didn't. No. Okay, and this works for any base. So if I had log base 4 of 3 to the x power, that would be the same thing as saying x log base 4 of 3. Okay? The second one you need to know is anytime you have log of 2 or more numbers being multiplied, you can rewrite that as log of the first number plus log of the second number. And once again, if you had a different base there, or if it's a natural log, this still works the same way. Okay? And the last thing you need to know is this one, log of x over y is the same thing as saying log of x minus log of y. Okay, so a couple of examples here I want to go over. And this one is very simple. You already know that 2 to the x power equals 8. What's x going to be? 3. You already know that. But I'm going to show you how to use logs to find that, okay? If you do log of 2 to the x equals log 8. And know that I'm doing this in base 10 because your calculators can do base 10, okay? I can rewrite this, the one on the left as how?
X times log.
Yep, x times log 2 equals log 8. Okay? So now if I wanted to solve for x, how do I do that? Yep, I'm going to divide both sides by log 2. So that would be x equals log 8 over log 2. And if you put that in your calculator, you're going to get 3. All right? Now remember, if you're using your phone calculators, you're going to have to put 8 and then push the log button, divided by 2 and then push the log button. Okay? Unless you have the ones that actually write out the word log and give you a parenthesis. Any questions on that one? All right, the next example I want to give you guys is this. 3 times 2 to the x power equals 8. And this one's a really good example because this is where the logs really come in handy for this. Because you can't do this on your own very easily. It ends up being a fraction or a decimal. So, if I were to solve this, I'm going to, first of all, take the log of both sides. Okay, now based on our rules, what can I do to this side right here? Well, before I can do that, I need to actually separate these out. These are being multiplied, so what rule can I use for that? Addition, right? So it'll be log 3 plus log 2 to the x equals log 8. Okay? Now we can take this x and put it in front here. So I could say log 3 plus x log 2 equals log 8. I need to solve for x, so what am I going to do? Yep, subtract log 3 from both sides. Okay? So now I have x log 2 equals log 8 minus log 3. And now what do I do? Divide by log 2. No. You actually, because that's not the same as log 5. Remember, if I'm actually looking at the minus, that's the same. This log 8 minus log 3 is actually log of 8 divided by 3. If you use that rule that I gave you before, this one right here, log of 8 divided by 3 would be like this, right? Okay, so I worked my way backwards. That's what that would be. So, no, you can't just subtract 8 minus 3, so it is not log 5. Yeah, if it was log, but you would take the log of it first before you subtracted, right? So that makes a whole different number. Okay? So so I'm just saying you can't subtract it. Okay, so x ends up being, if you put this in your calculator, 1.42. Yep. So you're going to put that in your calculator. You put 8, push the log button, minus 3, push the log button, divided by 2, log button. Okay. Yep. I'm going to take this one, 3 over 4 to the x power equals 64. Okay, so on this one I'm going to do log of 3 over 4 to the x power and log of 64. So what rule can I use on this one?
Log 3 minus log 4.
Good. Yep, log 3 minus log 4 to the x equals log of 64. I can move the x to the front of that now. So it'll be log 3 minus x log 4 equals log 64. Now I got to solve for x. So I'm going to subtract log 3 from both sides. So I'll have negative x log 4 equals log 64 minus log 3. If I divide both sides by log 4, I end up with negative x equals log 64 minus log 3 divided by log 4. And notice that this is negative. So if I put this into my calculator right now the way it is, I'm going to have negative x equals 2.21. So what is my x going to be? Yep. So x ends up being a negative 2.21. Yep, divide by negative 1. So this is one of the ones off your assignment for today. And one of the things you need to remember is anytime you take a square root of something, say I take the square root of 25. It does become 5, but I want to write this in exponential form. Do you guys remember what that would be? It'll be 25 to the what power? Nope, 1/2.
Hang in there.
Okay? So the square root of 25 is the same as saying 25 to the 1/2. If I had the third root of 27, how would I write that in exponential form? 1/3. Okay? So you guys are going to need to remember that you're going to need to transform it to this way first. Okay? So on this one, I can rewrite this as log base 4 of u v w to the 1/2. Now, using the rules that you have learned today, what do I do with that 1/2? Put it in the front. Now what's the next rule I'm going to use? Yes, I'm going to use the addition rule. Okay, so it'll be 1/2. I'm going to put a parentheses on this. It'll be log base 4 of u plus log base 4 of v plus log base 4 of w. Now, is it completely simplified? What do I have to do with that 1/2? Distribute it, and then I'm done. Okay? So that is the expanded form of this. So on all those problems that you see right there, you're going to be just expanding it. You're not solving them, you're just expanding them. Okay? On the next page, if you flip your sheets over, I want to look at number 17. 17 looks like a beast. It's not as bad as it looks.
Ooh, what a beast.
Log base 7 of 5 plus 5 log base 7 of 11 plus log base 7 of 12 divided by 2. Now, they want us to put it back into a condensed form. So we already have it in all of it spread out, but we want to put it back into condensed form. So, right now, this one, I'm going to leave B, but what can I do to condense this one? Move the 5 back into exponent, right? So this become log 7 of 11 to the 5th power. Okay? Now, one thing I want to point out is that this log 7 of 12 divided by 2, this can all be rewritten as 1/2 log 7 of 12. That means the same thing, right? Is timesing by 1/2 is the same as dividing by 2. So now it's easier to put it into exponential form. I could say plus log 7 of 12 to the 1/2. Yep. Yep. Okay, now what happens to all these? Okay, these are all going to be multiplied. Okay, so it'll be 5 times 11 to the 5th. Okay, 12 to the 1/2 is the same as saying what? Square root of 12. And that's the condensed form of this. Okay? For 14. Okay, so 14 looks like this. You have log base 5 of x to the 6th over y to the 4. Okay? So, first thing I'm going to do is what? What can I do with this 4? Put it in front. So it'll be 4 log 5 of x to the 6th over y. Okay, what rule am I going to use now? Subtraction rule. So it'll be 4. I'm going to put parentheses on this. Log 5 of x to the 6th minus log y. Base 5. What can I do to simplify this one right here? Yep. So it'll be 6 log 5x minus log 5y. And then I can distribute that 4. Okay? It's not that hard. It's just lots of steps. Okay?
That makes it hard.
Oh, no.
You underestimate.
Okay. last problem I want to do now. There's some on from 24 to 33.
That's it? Then we stop.
From 24 to 33, you're actually solving equations. So let's look at number 29, because this is where it gets to be very handy to have logarithms, because it's really hard to do this on your own without them. This is number 29. Okay? So 12 to the negative 6x minus 8 equals 46. Okay, so what I'm going to do here is take the log of everything. So this will be huh? Okay, so what do I do with this negative 6x here? You could do, yeah, you could. That would have been a lot easier. So let's go back and look at that. You're right. Sorry, PJ. So if I add 8 to both sides, this ends up being 54.
Yeah, it's on the negative 12.
Now we can take the log of both sides. That makes it better.
No, I use a pen, you can't do that.
Hey, I can change my mind. Okay, and then if you divide both sides by log 12, you have negative 6x equals log 54 divided by log 12. Okay? And then you divide it by negative 6. So that's it for today.